gets more and more advanced as you progress. Trust me, if you go through everything, you will come out the other end confident with React and be able to manage or even lead React projects at your company. Now, before we dive into coding, building projects, and learning about React, I want to take a moment and understand why React exists. What problem does it solve? Why it makes front-end development easier? And also, what principles we need to understand to be more than the average React developer. You see, a lot of times people learn a tool, a library, or a framework without understanding the core principles that make it great. By learning these things first, we'll have a foundation as we move through the course and understand what the best practices are. The goal of this course is not to be another React course like thousands of others already out there in existence. The goal is to make you a React developer that can think on your own, make good architectural decisions, and lead projects instead of only following tutorials. Therefore, in this section, let's dive into the important principles that will help us get through this course. If you are new to React, some of these principles may be hard to understand at first. Rest assured that we will keep revisiting them throughout the course as we learn. For those that have already worked with React, you may learn a thing or two, so hang in there. My goal by the end of this section is for you to be able to explain to other programmers the benefit of React without writing a single line of code. I do recommend that this section is something you come back to after you've watched through the entire course. Alright, enough talk. Let's get started. Now, React came out in 2013, but what do we have before then, before React? Well, the front-end landscape was very different. Initially, back in the 90s and early 2000s, we just had basic HTML, CSS, and JavaScript. HTML displayed the text on our web pages, CSS the styles, and JavaScript allows us to have some interactivity in a website. And initially, it just started with simple forms, where we send from the backend when we go to a URL all these files, and when a user, let's say, submits a form, we simply send that back to the server to store that information. Now, if a user clicked on, let's say, a link in the page, well, once again, we simply request the new HTML file and the new page from the server, and that gets sent to the front end. And that's how websites worked for many years. But there's a problem here. You see, all these websites were run on different browsers. And all these browsers were worked on by different group of developers. So each one of these browsers implemented, well, their browser differently. So what happened was, as we wanted to use more and more JavaScript in our web pages, we had to account for all these browsers that sometimes worked differently from each other. And we had to accommodate JavaScript to work with these different browsers. Now, eventually, we had jQuery come out, which allowed developers to easily interact with the DOM, or the document object model, across all these browsers. You see, back in the day, if we went to, let's say, Hacker News over here, clicked on Views, Developer, and then Developer Tools, and we went to Elements here, this is the DOM that, well, is our page. It displays exactly how our page should look like, and it's a tree-like structure. And JavaScript, all it does is modify this DOM. You can remove elements, you can update elements. And although there's now more similarities and compatibility across different browsers, back in the day, we didn't have that. So jQuery made developers happy because it had a unified, easy API that kind of looked like this. Instead of a developer trying to think about how to work with the DOM in each of the different browsers, jQuery said, hey, we'll take care of that complexity for you. Just this is the syntax we'll use that works across all browsers, and you can manipulate the front end or the DOM however you want. So that was great. But with this power, developers started building bigger and bigger applications. Instead of just something small we started getting these massive applications like Facebook where you got to log in, look at the newsfeed, message friends. And as websites turned into these full applications that people can interact with, besides just requesting more and more pages like a blog, well, libraries like Backbone.js came out because, well, our JavaScript files started getting bigger and bigger and bigger. Libraries like Backbone.js allowed us to organize these JavaScript files. And because it became easier and easier to work with the DOM, we had the birth of a single page application. You see, traditionally, we just had HTML files for each page, and every time we moved to a different page, we would request from the server, well, the HTML file, the CSS file, and the JavaScript file, which usually contain jQuery, for each time we clicked on a link. But with more advancement, like we had with jQuery, Backbone, and something called Ajax, we now had a different system. What generally happened now is we focus less on HTML and a lot more on JavaScript. You only load the application code once. Instead of us making new requests to the server, where we returned a new document, instead now, our applications acted more like a desktop application where we stay on the same page the entire time, and the JavaScript file simply changes or updates the HTML file or the DOM to display new things. So you were able to sign into an application and interact with that application without ever speaking to the server anymore. And this way of writing applications or single page applications became really popular. And in 2010, AngularJS, which was created by Google, really became the standard way of building applications this way. Now, unlike jQuery, Angular allowed developers to build these large applications by forming these containers that, well, wrapped your project. And because it was created by Google, it had a lot of power because people said, well, this is the way that we should build things. Everything's organized. We have these large JavaScript files, but we can organize them this way. You had code now that had better containers, where you had things like controllers, views, and models. And this idea of a model view controller, where each part of the application or each JavaScript file was divided into different things that it did. This idea of organizing our large code so they're easier to work with as teams get larger and larger really made AngularJS popular. But there was a problem. You see, things started getting more and more complex. Because of this, as things get bigger and bigger, more things have to happen. Users are clicking on this button, which changes this area, which in turn changes this area, which now has to display this information. We have more and more complexity now. And although frameworks like AngularJS came out, people started to notice it's getting harder and harder to find bugs in the code and understand how each part of the app was affecting the other. Meanwhile, Facebook developers were finding it hard as well on their end to maintain their app, especially their Facebook ads app. You see, the Facebook ads app got more and more features. More and more people were added to the team. Now, the growing number of lines of code, the growing number of people working on the app, their app became really difficult to handle. And each update would cause more and more issues where you had all these arrows relating to each other, pointing to each other. And after a while, the engineers of Facebook just couldn't keep up with the way that they had created this app. They needed to upgrade their code base. And this isn't just special in the front-end world. This is all over programming. It's why we need good architecture. We need to think about how we organize our code, how we manipulate data, and how that data flows through our programs. So Facebook came up with a solution. And that solution worked really well for them. That in 2013, they released React to the developer community at JSConf 2013. And their solution was really good. And it took off because React developed a whole new way to build front-end applications. Now, it also happened that in 2014, AngularJS realized that the way that they've architected their framework just didn't allow good applications to be built anymore. So they decided in 2014 that they were going to rewrite the entire library, call it Angular. But because they wanted to do an entire rewrite, a lot of people during that time moved to React. So combined with the fact that AngularJS was getting a complete new rewrite, Facebook was backing React. And the great principles that React introduced made it what it is today. That is, it became the most popular front-end tool with the most job demand across the world and being used by very large companies like Airbnb, Uber, Netflix, Twitter, Reddit, Pinterest, Wix, PayPal, Stripe, Tumblr, Walmart. However, what made React so great? What were these principles that made it jump from something that Facebook used to something that developers all over the world use? Let's find out in the next video. Now, the success of React comes down to 4 key things. And these React concepts are what we're going to go over in the next 4 videos. But in this one, let's talk about the first one. And the first one, React says, hey, don't touch the DOM, I'll do it. What do I mean by this? You see, many existing frameworks and libraries before React were directly manipulating this DOM on every page. First, let's just go over what a DOM is. If you remember, DOM is our document object model. It's what the browser uses to display, well, a website or a web app. And JavaScript is simply manipulating this DOM. That's all JavaScript is doing. For example, if I right-click over here and select Inspect, you'll see that here, if I click on Unvote, we'll get a little flash saying that, hey, JavaScript just updated this. If I click again, I get a little flash. The DOM is just the tree representation of the page. We start all the way up from the HTML tag, all the way down to the body through each individual element. And websites were built using things like this. All these ways that browsers allowed us to manipulate the DOM. They gave us the DOM API that we could access using something like inner HTML or get element by ID, get elements by tag name. This API allowed us to traverse the DOM, access any node we wanted to, maybe remove them, add new nodes. And before React, this is what libraries did. You either did this manually, or you used jQuery, or you used some sort of a library that allowed you to use this in a simple fashion. You see, this way of programming was called imperative. That is, in an imperative paradigm, you directly change individual parts of your app in response to various user events. So you had, let's say, your JavaScript file. You'd say, hey, if user is logged in, well, then go change that little icon over here to the user's profile. And now that the user is logged in, well, also show profile page. Okay, so JavaScript goes, changes the DOM, and updates the profile page. And then, okay, now that we're also logged in, we also need to display friends. Okay, let's do that as well. Modify the DOM. And all right, that's good. We're good. Oh, by the way, it's been 5 seconds and we need to display a chat over here. Okay, I'm going to go and do that. Now, this sounds intuitive, but the problem with this imperative approach is that it becomes difficult to see the relationships between events and all these edge cases. Remember this diagram over here where we had AngularJS that all of a sudden had all these relationships affecting each other and all these arrows pointing to different things? Well, instead of this imperative approach, React came up with a novel concept, a more declarative approach. And this is what React says to you. Hey, DOM manipulation is one of the biggest performance bottlenecks. It takes a long time for DOM changes to happen, the browser has to do two really intensive operations. One is to repaint, that is, change an element and add it onto a page. And then reflow, which is to recalculate the layout of the page and move things around if need be. So changing the DOM was a really expensive operation. So React says, hey, you know what? Let me take care of that. I'll find the best way for me to change the DOM and just declare to me what your app looks like. So all we need to do is say, hey, this is a JavaScript object of how I want the app to look. And React is going to hold this JavaScript object, this massive blueprint of how things should look. And based on this blueprint that we give it, well, React just says, hey, just tell me what the page should look like, and I'll take care of it. I'll do everything for you. I'll find the best way to use the DOM. You're never going to touch the DOM. Just tell me what the page should look like. This declarative paradigm is called that because we declare that, hey, this is what the state or data of our app should be like. And based on this state, well, then just make those changes. So if user is logged in, then React already knows exactly what to update and what to do. Now, this idea of a declarative style meant that we didn't have to directly say, do this, and if this happens, then do that, where we just say one by one exactly what should happen. Instead, we tell it, this is the state of our app. And React automatically just does it for us. The difference is that all the different states are accounted for in one place. That is one big JavaScript object that describes how our app should look. And this resulted in less complexity, better code quality, and faster developer times. So it created this whole idea of, hey, you can build web interfaces without touching the DOM. And this is where the name React came from. The name React is simply saying, hey, based on whatever the state or data of the app is that describes our app, I'm just going to react to it and change everything for you so that you get the display that you want. So we learned that React had this revolutionary idea of, let me handle the DOM updates. Because I know the best way to do them, the most efficient way. You don't have to do that. Just tell me what the page should look like. Next, big game changer was this idea of building websites like Lego blocks. React is designed around the concept of reusable components. Just like you see in this app, how each square or rectangle has different color. Well, these are all components. Each of these individual pieces create this whole app. React had this idea of small components that you put them together to form bigger components. So you had the profile picture component, you had the add component, and then you had the navigation bar component. And within here, you had components containing components. So you had a component in here that was surrounded by another component that was surrounded by an even bigger component, just like Lego blocks. And all these small components, whether they're large or big, can be used in different places. For example, I can have this component just copied over to multiple locations because, well, they're the same thing. And I can even move these over to different projects and reuse them. So people can build these components, like material UI components, that I could just copy and paste this code and add it to my projects, like so. You had different component libraries, like React Bootstrap again, or something like Blueprint. So people can now share these components across different websites, across different projects, and they will all work. Now, this idea of components in React, in a simple term, is just plain JavaScript functions that we write. So we have the state of our app, or that is any data that describes our app. For example, the user is logged in, whether it's true or false, and maybe friends. Then components are created based on that data, well, simply as functions. And don't worry, don't get intimidated by this. This is something that we'll cover throughout the course. But components are simply just JavaScript functions that receive some sort of input or attributes, which we call props. And in return, it returns this thing that kind of looks like HTML, but inside of JavaScript. And these components can be built like this as a function or even as a class. But the key here is that based on the state and these components that we build, we have an entire component that we can add to our page and reuse maybe over here as well if we wanted to. Just like Lego blocks. Now, here is a simple React to-do application. And I'm going to be using something called the React Developer Tools, which I recommend you install as well in the Chrome Web Store. You can add it to Google as an extension, and what it allows you is when you click View, Developer, Developer Tools, you'll now have the Elements tab, which shows you the DOM of your app, which you can see over here, but also a new tab called React. And this React plugin actually allows you to see the components that we build into an application. Now, you can see over here that this isn't exactly HTML. We're creating custom tags like header or filtered list or footer that isn't valid HTML, but you'll see that inside here, all of these are actually, well, built by HTML elements like header, h1, or input. So again, this idea of a components architecture means that we can have some sort of data about our application, and we build these components ourselves. And these components are what we call React components that we built out of HTML tags that signify a component. And each of these components work together to eventually have our app. And this component architecture is really, really key in React because it allows us to reuse and share components between projects. So that if you wanted a date picker on your app, well, instead of maybe building it yourself, you can just Google for it and say React date picker component and just use somebody else's code. But there's two more key concepts to get through. So let's do that in the next video. So we've learned the first two concepts. The third concept that made React really popular is this idea of unidirectional data flow. What do I mean by that? Well, so far we understand that React is just a JavaScript library that allows us to write more JavaScript to have interactivity on our websites. And in React, we have this idea of state, which you can think of it as a JavaScript object that describes our app. So all the data of our app is within this state. And then we also learned about this idea of components that we can build using React with this weird HTML looking thing, but inside of our JavaScript files. This idea of state, which is the data of our app, works with the components, which are built using what we'll eventually learn is called JSX. So it's HTML-like syntax inside of JavaScript. And these all combine to essentially give our React library two things. That is the components that we've built, the state of our application, and you can think of this as a function. A React library is simply a function that we give all these things to. What it's going to do is it's going to create what we call a virtual DOM. That is, it creates a JavaScript version of the DOM. Remember, this isn't the DOM. We installed the React plugin to have something that looks like the Elements tab, but isn't exactly. And this is just a JavaScript object that describes our app into what we call this virtual DOM, which is a tree-like object like this that gives React a blueprint of how it should update the actual DOM. So what happens then is React takes all of this and says, hey, here is the actual DOM, or the document object model of the website, and the React little bot over here is going to go look at the blueprint of what it needs to build and modifies the DOM for us. Now, this idea of a unidirectional data flow means that anytime we want something to change on our web page, well, the state has to change. That is, the data has to change in our app. So what happens if, as a user, I click on, let's say, a button? Well, I click on a button. React is going to intercept that and say, hey, somebody just clicked on the bottom. How does that, let's say I click on the sign out button. React is going to say, hey, somebody just clicked on the sign out button. How are we going to change the state? Well, internally, we would say that if somebody clicks on the sign out button, we're going to change is logged in to now say false. And React, as soon as the state changes, reacts to that change and says, hey, the state just changed. Combine the new state and the components we have and update the DOM. You see, the data only flows one way. A better way to think about this is like this. Our application is simply built with this virtual DOM, this JavaScript object that describes our app. And as soon as a state changes, it's going to trickle down that information and let everybody know, hey, the state just changed. If is logged in is now false, display this version of the app. Data can never move up. So for example, the state, as we'll learn, can live in different locations, different components. And if the state, let's say, changes here, the data can never move up. That is, all these changes can only trickle down. Now, this concept is hard to explain without actually seeing it in code. So if you don't get this right away, don't worry. We will explore this idea and revisit this idea of one-way data flow throughout the course. But the key takeaway here is that by having this restriction of data only being able to move down from the state of our application all the way to the DOM, and if any changes or events happen that change the state, well, we go back to the state, and that state change trickles down to different components in one direction, is a restriction on how data can move through our app. And by adding this restriction, it's really easy to debug code. For example, if there's something wrong with our sign-out function, I can go to wherever the state is logged in lives. Let's say it lives in this top component here. I can go over here and know that this is where the bug is happening. And whatever's underneath this component, well, that's it. I don't have to look outside of the component, or if this tree was massive with thousands and millions of components. I only have to look in the place where the data exists and where the data flows through. Again, this is a really hard concept that we will explore throughout the course. But this idea of one-way data flow is the restriction. And because of this restriction, it's easier for us to understand how our app works. Unlike the arrows and points that we saw with an Angular app, where things got confusing really, really fast. So we've learned that React takes care of DOM changes for us using something called virtual DOM. We learned that we build the websites with components, and this idea of unidirectional data flow, where data only flows one way so that it's easier to debug our code. Then the final thing that really made React stand out is this idea of, hey, I'm just the UI. The rest is up to you. What do I mean by this? Well, remember how with Angular, it came with all these things built in? That is Angular.js. It was a framework. And a framework is kind of like a whole kitchen. It gives the developers all the tools necessary to build an application. So if you're a cook in a kitchen, well, you get the oven, you get the knives, you get the drawers, you get the pots and the pans, you have the stove, you have everything for you, and this is how you cook, or this is how you build a website. It's very opinionated. On the other hand, React said, hey, I only care about this whole idea of components and virtual DOM, and I only am going to work with the view, the user interface. Everything else that you need, well, you can just use other modules, other libraries, and mix and match and have whatever you want customized to your need. So it was a library, a UI library, which is not like a kitchen. It's more like, let's say, the stove. They gave you the stove to cook your soup on, but everything else, like knife, cutting board, spoon, well, you can pick whichever one you want. It's up to you what you use to build that soup. All we give you is this oven. And the key idea was that because it was so small, you can learn once and write anywhere. What does that mean? Well, React doesn't make assumptions about what technology stack you use. All we give you is, hey, here is this idea of components, of a blueprint that we can use, a massive JavaScript object to make changes. And here's also a robot that, well, interacts with the DOM and makes changes for you. But because of this, we actually are able, because it only focuses with the UI, we're actually able to move React to other places other than, well, let's say the web. For example, we now can have different robots that interact with different views, and all they need is this main React library or blueprint of how to, well, look at a JavaScript object and say, hey, change this UI. So now you could have things like React Native, and this little robot can look at this blueprint and say, change the view in a iOS app, an Android app, and although it might not know anything about the DOM, it only needs to know about views in a mobile app. You also have things like React 360, which is VR apps. And again, using this blueprint of React, I can use it for VR apps, and this little robot or library can focus on VR. We also have things like Electron and React Desktop that allows us to build desktop applications, and they interact with Windows and Mac OS and Linux operating systems. We even have things like React Blessed that work with the terminal and the command prompt. And because of this, React was able to use this concept and have developers that originally just wrote for websites on the browser to now use the same idea and the same principles and the same JavaScript code to build desktop applications, to build VR applications, to build mobile applications. And this idea of cross-platform really took off with React. And you'll notice when we start building our projects that we actually import two libraries in React. The core React library, which is this little robot, and the React DOM library, which is this specific robot that only knows how to interact with the DOM, or the web browser. We learned the four main concepts that really made React take off. It gave developers a whole new way to think about their applications and how we built them. And it was architected in such a way that it made building large-scale applications a lot more pleasant than what we had before. Now, since then, a lot of libraries have come out that have taken some of the React concepts. Angular was rewritten to a new version that is more in line with these concepts. Libraries like Vue are also using these concepts because people have realized that these are some really good principles. So now you have things like React, Angular, Vue that developers are using to build front-end applications. But React really had this initial jump, and it's still the most popular library and the library with the most job demand because it was the first to introduce these principles. And the beauty is that although we haven't written any code, you've now learned a little bit about some of the keywords that we'll encounter throughout this course. And don't worry, you're not supposed to get them 100% just now, because all of these things are something that we need to practice, code, and build projects with to really understand them. But now when you hear the words like declarative, JSX, components, state, props, virtual DOM, you'll at least have an idea of what it is. Because we've learned that React is a declarative paradigm. That is, instead of telling our apps exactly what to do, we simply give it some state, some components that are built with something called JSX, and these components sometimes receive properties, which are called props. We give all that information a giant JavaScript object in a declarative way, which creates a virtual DOM in JavaScript, and that virtual DOM is used by the React library to update the DOM for us in a declarative way. But your question is this: how do I become the best React developer I can be? And to be a great React developer, it actually comes down to three things. Three things that really, really good senior React developers do well. And we're going to focus on these three skills throughout the course. The first one is to decide on components. Really good React developers decide what is a component. How much do we want to break down a component? How do we build these reusable components as we've seen? And deciding on how to break down the app into different components is a very important skill. The next thing is to decide the state and where it lives. Now, we're going to explore this idea of state or data of our app a lot more, but this state can live in different locations in our virtual DOM. So whether we put the state here, or we put the state here, or here, or here, or in multiple locations, that decision is very important in architecting your app. And really good React developers do a really good job placing state in the appropriate component. The third is, what changes should we make when the state changes? Based on what this JavaScript object called state is changed, we have to decide what to re-render, what part of the virtual DOM changes. And deciding on this is also important because it has huge effects on performance. Now, don't worry, these are the things that we're going to really work on, but I want you to keep this as a reference, because if you want to become a senior React developer, these are the things that you have to become really good at, making these decisions and knowing when something is good, when something is bad. We're going to explore that and a lot more in the next section. I'll see you in the next one. Bye-bye.